Hello, everybody. My name is Camilo Chacón Sartori. I am PhD student in Artificial Intelligence Research Institute from Spain. And I would like to present about boosting and genetic algorithm with uh, graph neural network for multi-hop influence maximization in social network. Uh, I think we all use some social network. Um, Social networks are part in our all your life. We all uh, we all use it in one way or another. So many problems in social network can be modeled as combinatorial problems. Okay, therefore combinatorial problem can be represented as graph. Okay, and for example, in this image, the people are agent or node in the graph. Their relationship between them are arc. Okay, so um, in the other word, we can use uh, we can use we can use the directed graph to represent a social network problem. Okay. Okay. There are many problems in social network. One of them is the classic question: how can people influence others? The very important question in the social network problem. Okay. Um, Social network are all about connection, relationship, and exchange message with people. Okay, so and so for one person, um, can maximize their influence of other is very relevant for us. Okay, that for that reason, if we know which person can have the most influence, we can make better decision in our system. Okay, this problem is called influence maximization. Okay, there are variants for this problem. One is multi-hop problem. This particular problem has two constraints. The first is the fixed number of influencers. Okay. The second is the limit of hood. Later I will explain it. Okay. Well, then in this paper we work on this particular variant problem. Literature review. There are three critical papers we use in this work. The first is the survey integration of machine learning meta heuristic. The second is the proposed heuristic with take into account the probability of each node in the network for contributing by influence spread. And finally, the third paper is in particular, is very relevant for us because we can use this paper. Well, they presented the fast cover and supervised learning framework, multi-hop influence, is very relevant into integration into meta heuristic. We use this framework in the integration into meta heuristic in design hybrid algorithm. Okay. So the identification of a group of users who can influence as many people as possible is a problem called influence maximization. The following slide deal with the definition of the problem using a toy example. Okay, toy example. Multi-hop influence maximization problem has three input. Okay, three input. The input number one, a directed graph G with two components. The a set of B node represent agent or user of the graph, okay, and a set E are representing the connection between them, okay. The input number 2 is an integer number K, which is the number of the best, the very important, the best influencer of the whole network, okay. The input number 3 is another integer number, which is the distance of the node to be covered, okay, or the number of hops to be covered from node, okay. Okay, for example, the input K equals to 2 and D equals to 3. Okay, so the algorithm called select two nodes, B4 and B5. Okay, the first iteration, or the first hop, so this node cover this node B3 and B7, B6. Okay, in the next iteration, second hop, the new three nodes are covered, B2, B8, B11. Okay, final iteration is another cover, B1, B9, and B10. Okay, the output in these instances, the output is the set of K, B4, B5. That means it's the best influencer in the graph. Okay, if the number of are covered is a 9. Okay. Well, our solution method is a hybrid algorithm. Okay, the integrate the different two approach to optimization. The first one is the GNN or graph neural network. It's a class of deep learning method. Okay. The second approach is the genetic algorithm. It's a class or a metaheuristic algorithm. Okay. So we goal is to outperform this algorithm separately. Okay. So we hypothesize that hybrid algorithm is better than both standalone algorithm or technique. Okay. Okay. But a critical question is why design a hybrid algorithm? Okay. Because some heuristic do not always achieve a good solution. So integrating a learning technique is appropriate strategy to improve its performance. Okay. GNN, the first method in the integration. GNN is a class, the deep learning method. The main difference with a standard deep learning method is that GNN directly use the graph structure in the prediction for node or for arc or for a subgraph. Okay, these are three typical prediction in the GNN. Okay. Therefore, it's more flexible, more useful with problem using graph. Okay. This is an example. The input, the GNN, input K equals 2 and D equals 3, and output is the all probability on the all node in the graph. Influencer with the highest probability is B4 and B5. Okay, this is output the GNN framework. Okay. Second method, by random key genetic algorithm, has two parts to handle the problem. Okay, the first part is the problem independent because its work with population is individual, that a vector of a real number. Okay, the second part, on the other hand, the problem depend this line 2 and line 7, right? Is more relevant because the individual are translate into solution to the tackle this problem. Okay. The next slide. Okay, it's a very important slide. Integration, the genetic algorithm, GNN framework. The idea is to replace this equation, the function evaluate line 2 and line 7, with a new incorporate probability from GNN framework. The hypothesis is a good prediction we give us the better result. Okay, the integration is include the P sub A probability GNN framework. Okay, this is the pipeline. This is the pipeline of process. Okay, there are two steps. The first step is offline, is the last part. Okay, where is train and evaluate the graph in the GNN. Okay, the training step using a set a small Erdo raining graph. Erdo raining graph is a random graph type. Okay, but synthetic type. It's very useful in social network. Okay, for problem for generalization. Okay, the train. Okay, the next the right part is the GNN model to evaluate an unseen graph. For example, real world graph. Okay, so we training a synthetic graph, random graph, after we will evaluate a real world graph, the unseen graph. Okay, it is the training step. The model generates for K and the same. The very important here is the number of models generated depends on the K value. Okay, one K value need one model. Okay, so the very important. In effect, the model number 1, the K is 32, and the D equals to 1 is one model. The model, for example, model number 2, K 64, and D is the number of foot. Okay, it's very important. All model we use D equals to 1. I explain this later. I will explain it. Okay, result and our hybrid algorithm, so integration algorithm, the genetic is to be genetic algorithm must fast cover is the GNN framework. Okay, obtain the best result in the most real instant. We use 19 instances. All models were training the synthetic graph to evaluate later real world graph. Okay, all models we're training with the very important because we're training in D equals to 1 to evaluate later with equals to 1, but also D equals to 2 and equal to 3. Therefore, is proof they generalize because the training and fast cover or genetic graph neural network framework, the training synthetic graph are evaluated later in real world. But the result is 4K equal to 32 hybrid algorithm. Our hybrid algorithm wins to 73 of the case. The K equal to 64 in 71 wins in 71%. for 108 in 60 seats, winning 66%. Okay. This percentage probability decrease, decreases 73 and 71 and 56 because the entire model was training with d equals to. Why? Because for computational time, because the if we train our model with d greater than to 1, the computational time increased so much. So I decided to use only d equals to 1. But generalization is good for d greater d value greater more than 1. Okay. We use HTN. HTN is the search trajectory network to analyze the result. Okay. Red point in the center, the ping, the line is then our algorithm. It's better because trajectory are concentrate close to base value. It is a very useful visual tool for comparing multiple optimization algorithms. Okay. Conclusion: hybrid algorithm is improved genetic algorithm and GNN framework separately for the multi-hop influence. Future work incorporate the same methodology of the hybrid algorithm into similar problem. Thank you for attention. I know Neo4j, but in this case, the instances, I don't say it, but we use a SNAP dataset, the Stanford dataset, very popular. So the instance is very large. So maybe I will know good result if use Neo4j. I don't know, but maybe I think. Yeah, I only probability for a node. No arc or edge. But so only output the best highest probability for a node with the input. Yeah, it's a very good question. I will explore it the type relationship. Thank you.